Hello everybody. Welcome to week 6. So in this session I will teach you what is the relational algebra. So this is the content of this slide. So we'll talk about the basic operation, selection, uh, projection, combining selection, restriction, Cartesian, union, set different, intersection, complex operation and temporary set, join, aggregation, grouping, and the last one is summary. So, what is the relational algebra? Basically, it's a theoretical language with operation that work on one or more relation to define a new relation without changing the original relation. Relational algebra illustrates how the relational model is based on set theory. The practical implementation of relational algebra is SQL. As always, there are several variations of syntax, even in the theoretical science of relational algebra. These lectures just show you the most common symbol. There are five operations, the basic things in the relational algebra. First one, selection work on a single relation and extract only those tuples that satisfy a specific condition. The result is a new relation with subset tuples. Projection works on a single relation and extract only the desired attribute. The new relation contains a vertical subset of the content of the original relation. The Cartesian product needs at least two sets. Every item in each set is combined with every item in every other set. If you are still awake, you might be given to wonder how this is useful. Most entry in one set of item you will think as specific to one of a few items in another set. You're right. You need to know about Cartesian products mostly so you know how to avoid them. Union consists tuple from two tables or tuple from one table that fulfill different conditions. Union is just a combination of different set of tuples. Set different find all tuples from relations that are not found in the other. Intersection find all the tuples that two sets have in common. If this sounds very theoretical, that's because this is a theory. So this is the basic operation. Selection is a projection. And the last one is a combination. Sorry. In many actual queries, we need both restriction and projection. This is because many relations have lot of attributes, and showing them all is only confusing. If we combine selection and projection, we work in a set of a set kind of fashion. We extract a set and then give it to the next operator as selection. So here we execute the selection in the parenthesis first and then give it to the projection in the parenthesis where we used to have the name of the relation. We now have the outcome of the selection. So the selection of the properties with three rooms happen first, and from the result we pick only the attribute that has the property number, which is a unique identifier of the properties. We could of course use other attributes as well if wanted. If we couldn't or combine operators, the possibilities of relation operator will be pretty limited. So this is the Cartesian product. Relational algebra can be very complex. So we need a way to subdivide the step into smaller ones. We can then read the operation like an algorithm. This way our head don't explode when we try to find out what is going on. Using the assignment operation denoted by the an arrow, we can assign an operation to a specific set variable. In this example, we have two temporary set and a final result set. In this example, we are making another Cartesian product and two projection. We can execute the projection operation first and put each result in its own set. First, we get the result of the projection from client and assign it to temp client. Then we get the result of the projection from viewing and assign it to temp viewing. Now we can create the Cartesian product of temp viewing and temp client and assign them to result. When we know the result variable, we can either mention all column names or omit them, whichever way we prefer. So this is the join operation. Basically, join operation are the answer to our predicament with a Cartesian product. Joins actually use a meaningful column to join tuple from different tables on. So this kind of operation you need quite a lot when working with relational database. Equijoin means the join operator is an equal sign. This is probably what you expected, and it is by far the most common operator on which to link two tables, but it isn't the only one. You could use less than or greater than just as well. A natural join is an equijoin that joins the entry of two tables based on the table that have the same name in both tables. It exists in many database products. Natural joins are a concept you should know about at the time you are modeling your data. If you use different names for columns in different tables, or worse still, the same name for columns that don't mean the same, you can use natural joins. By default, joins are inner joins, meaning that if you are join row from two relations, if a tuple has no matching tuple in the other table is excluded. Sometimes that's not what you want. If you need to include tuple that have no match in other relation, you have to specify an outer join. A semi-join is a join where only attributes from one of the relation are included. This can be very practical. Essentially, it means you are picking row from a table by creation that is specified in another table. So this is the example of the natural join. And then this example under the example for outer join. This example from for aggregation operation. And the last one, this is the example for grouping operation. As summary, we can say the relational algebra is like a theoretical language which with operator that works on one or more relation to define another relation without changing the original ones. Basically, it consists of many operations that perform basic tasks such as selection, projection, Cartesian, union, intersection, and set difference. It can also be used to join two relations with the different join operation. Aggregated and grouping operation assist in producing results that are of interest which contain specific value based on the relation. Relational algebra is the theoretical underpinning of SQL queries. If you understand the basic relational algebra, SQL might be easy. So this is the summary of this online lecture. So for me, it's like a joining process, which is, sometimes we have a For example, we have a 4 table, and then you want to we want to get the output from different kind of table. So of course, we will use some kind like a command that can extract diff or extract the data from different kind of the table. So in this case, we need to use relational algebra. So which is we can use join, like a selection, projection, union, intersection in order to extract data from different kind of the table. Sometimes the table is not only in our database. Maybe it can be the table can be located in different database which is in different server. So the structure of the database at first may be quite complicated. So the purpose of the relational algebra is to the query make the query or process to obtain the data more easier. So this is the original purpose of the relational algebra in the SQL DDL. So I hope by teaching you guys about the concept of this relational algebra, after this maybe you can more understand how to implement this kind of the operation such as a selection, projection, Cartesian, union, intersection, and such different in the SQL DDL, because we will implement this using this thing in the SQL DDL when creating the table, when calling the data or calling data from the table. I think that's all for the online lecture session today. So if you have a question, just raise up in the Canvas user so easier for me to answer it. And then for the week 6 lab, you need to form a group at least 2 until 3 people. Actually, my plan is I want to my student to form their own group. But however, there are since this class so many students, 70 plus students, and then many students keep calling me asking me to find the team member from them. So I think uh in simplified way, I just produce the group list so that I think I already published in the Canvas discussion. You can straight away go to the list and then find which name you are, which group you are, and then please contact your group member and be prepared for the week 6 lab session. Actually, week 6 lab session there's nothing new. In the week 6 lab session, we need to develop EIRD. Same thing with the different one. But the different things in the this week lab session, you need to get it the case study in the from the real case study. For example, you want to there is a what we call the kilang Nestle. I mean the Nestle factory uh, in the Sarawak, and then you have somebody which is you are familiar with the Nestle factory. So maybe you can ask your the to the familiar people that people, and then in order to draw the ERD diagram. So the different things is you will draw the ERD based on the real case study. So since this is involve quite of lot, I mean quite of work, so that's mean you need to have like a group so you can distribute the task between among you guys, and then in order to make this lab session, this lab. After that, after finish everything, you can submit it to the canvas discussion separately in your account canvas. For example, you have a in your group you have a 3 members, right? And then each of team member need to submit separately. So that's mean we can assume in one group there will be a three duplicate answer lab assessment. So that's all that you need to do. Mm, if you have a problem, just contact me and message me. But I hope please don't form your group your own. You need to refer at the list that I given in the canvas discussion and see which are group that you are belong. I think that's all for today. Okay, thank you.